Hello everyone. Today, I would like to explain how to utilize and set up the Sumitomo's molding machine feature, FFC, which is effective in improving defects. What kind of problems do you have at your production site? There may be many problems, such as a flash, short shot, weld line, material burning, warpage, and other defects in the product itself, as well as a remaining product in a cavity and clogged air vent. We, Sumitomo Heavy Industries, are developing an integrated technology application, Zero Molding, that eliminates such problems. Zero Molding is composed of three elements. MCM, that enables low clamping force molding without defects, by equalizing the mold clamping force, and improving control precision. FFC, that controls the material flow front, and realizes cavity-balanced full filling, smoothly at low pressure. And SPS, that helps to set and operate these functions easily. This time, we would like to focus on the FFC, the technology to optimize the flow control for a balanced filling. Well then, let me explain how it works. FFC is an abbreviation for flow front control and is a technology that enables smooth complete filling at low pressure by controlling the screw position at VP switchover. Specifically, about 90% of the product is filled in the filling process, and the remaining 10% is filled gently, using the viscoelasticity of resin, to achieve complete filling. To begin with, I would like to explain a little more clearly about viscoelasticity of resin, so that you can have a concrete image of how it is used. Viscoelasticity, as the term implies, is a property that has both viscous and elastic characteristics. Viscosity is the stickiness or thickness of a substance, and elasticity refers to the property of being deformed by an external force and returning to its original state when removed, like a spring. Resin has both the characteristics of viscosity and elasticity. The viscoelastic property also appears in the forward and backward motion of the screw in the cylinder during molding. Now, let's imagine the relationship between the pressure and the resin volume when the tip of the nozzle is closed with a stopper and the screw is advanced. In order to make it easier to understand the resin pressure state in the cylinder, here, the pressure is indicated by gauge and color. As the screw moves forward, the resin is gradually compressed, and the resin pressure increases. Then, as the screw retracts, the volume of the resin returns to its original volume, and the pressure decreases. This is the characteristic of the viscoelasticity of resin. Now imagine, what happens if the stopper at the nozzle tip is removed, while the resin pressure inside the cylinder is high? The resin flows out vigorously, and the pressure inside the cylinder drops. FFC is the technology that takes advantage of these characteristics. By stopping the screw and filling the last 10% gently with viscoelasticity, it allows for smooth full filling at low pressure. From here, let's go into details of how it works in the actual molding process. I will use the molding of a smart key as an example. The mold for this product is configured to be able to mold 3 different shapes of molded products for 2 sets at a time. Let's see how the resin is poured into this mold. The filling balance differs in this mold because of the difference in the size of each molded product. For example, at this stage, there are full-filled and short-shot products. These short shots occur due to their larger volume than the others. How would you handle this situation? Many people will move the screw forward and proceed with further filling. Even with that method, these incompletely filled cavities can be completely filled. However, by forcefully filling the mold, the resin pressure is increased too high, and flashes are more likely to occur in the portion where the mold contact force is weak, such as runners and a gate. In addition, since the fully filled cavities are also further filled, a flash may appear or the cavities may be overpacked, and then the product may remain in the cavity. As a common solution to these situations, the speed and holding pressure parameters can be set in multi-stage, but knowledge and experience are required to set detailed parameters. However, what happens when it is filled using the viscoelasticity of the resin, like the FFC, the method we introduced earlier? The FFC function does not move the screw, but stops it completely for a certain period of time. While the screw is stopped, the viscoelasticity of the resin, the so-called restoring force, is gently transmitted to the mold side, allowing the resin to flow slowly and completely fill the cavity. Since the screw is not forced forward, the resin pressure decreases, resulting in smooth filling at low pressure with no flashes, and at the same time, cavity balance can be maintained. Now, let us show you how to use and set up the FFC function. FFC is very easy to set up, and can be done with one touch. Just by turning on the FFC setting, Auto Mode on the molding condition screen, the molding machine will automatically set the time for the screw to stop, as explained earlier. The time during which the screw stops is called FFC time. Next, let's take a look at the setting procedure for actually making molded products. When setting the injection conditions from scratch, first check the filled volume at each VP switchover position, using a method called the short shot method. The short shot method is a method of finding an appropriate position for switching to holding pressure, by checking the filling volume at each position, while changing the VP switchover position little by little. This short shot method is a very important basic knowledge in injection molding, so let's take this opportunity to deepen your understanding. Now, let us show you the specific procedure for finding the appropriate VP switchover position. First, in order to exclude the influence of the holding pressure, let's assume that the pressure at the pressure holding process is 0 MPa. Then, perform molding, while gradually reducing the value of the VP switchover position to increase the filling volume in stages. After every shot, take out the molded product, and visually check the filling volume. When using the FFC, determine the screw position that is exactly full-filled with the FFC setting turned on. Now, we have found the proper VP switchover position when using the FFC. By using FFC, it is possible to fill at low pressure without increasing the filling pressure. In this state, the molded product will have sink marks due to shrinkage, so the holding pressure is gradually increased to improve the sink marks before completing the product. In this way, the FFC can be set with a single touch, and there are no particularly difficult molding procedures, so you can use it with confidence. By the way, the previous explanation is the procedure for setting the injection conditions from scratch, but there may be many cases where FFC is used for existing molding conditions. In such cases, there are some points to be aware of. When molding with the FFC function, the VP switchover position value is often set a little larger than the value used in the conventional molding, because the viscoelasticity of the resin is utilized for filling. Since it will be possible to fill up completely while extending the flow length at low pressure when using FFC for existing molding conditions, determine the VP switchover position again with the FFC setting, auto turned on. Next, regarding the time for FFC, first try molding in FFC automatic mode. This function automatically calculates the time. However, this automatic mode is not universal for all articles. For example, in the case of long products or extremely thin-walled products at the filling end, viscoelastic force alone may not be sufficient to fill completely before the resin solidifies. Also, in the case of resins that solidify quickly, it may solidify around the gate during the FFC time, making it difficult to apply the holding pressure. In these cases, the FFC timer can be adjusted as desired with time mode of FFC. Finally, I would like to introduce some molding examples using this FFC function. The first is a product called card cover, whose runners' distances are unequal, as you can see. The resin used here is PE, with 100% regrind material, and there are 8 cavities in the mold. In this case, the use of FFC in the molding process has led to reduced wear of mold parts and improved the defect of product remaining in the cavity. First of all, with regard to molds, if excessive mold clamping force is applied during molding, the wear of components will progress. The low-pressure filling by FFC and the resulting low mold clamping force reduces wear on mold components, which leads to extension of the mold maintenance cycle. This molding has unequal distance runners, which results in a filling balance. The inside tends to be filled easily and the outside tends to be a short shot. Normally, in order to fill this short shot, the VP switchover position value is reduced, and the screw is advanced to increase the filling amount, but of course the filling pressure will increase. However, since FFC allows filling using the viscoelasticity of the resin, it is possible to fill completely without increasing the filling pressure. As a result, it is possible to reduce the mold clamping force, which was set high, due to concerns about the occurrence of flashes. In this case, it was possible to reduce the mold clamping force to 100 kilonewtons, which was previously molded with 300 kilonewtons, resulting in less wear on the mold components and extending the mold maintenance cycle. Next, let's look at defects of overfilled product remaining in the cavities of the fixed side mold. The weight of short shot moldings is shown in this graph. In the case of the normal molding method, the product is filled by reducing the VP switchover value, so the holding pressure is applied while the product in the center cavity is overpacked. On the other hand, when FFC is used, it is filled by the viscoelasticity of the resin, so the holding pressure will be applied with a certain weight balance. Assuming the black line on the figure is the boundary where the cavity remaining defect occur, the product in the center, which was overpacked by conventional molding, will remain in the cavity. A common measure to prevent this is to increase the cooling time, but using FFC eliminates the need for this, so it is possible to reduce unnecessary cooling time. In this case, it was possible to shorten the cycle by up to 6.5 seconds, which greatly improved productivity. The second example is a product called coil bobbin. The resin is polyamide, which is prone to gas generation during molding. By using FFC for this molding, it became possible to improve gas-related defects, such as a short shot at the filling ends and material burning, and to enable molding with a single velocity and pressure condition. Gas burning refers to the burning of material at the end of the product due to compressed gas that is not released properly when the resin is filled at high speed. Therefore, it is necessary to set molding conditions that facilitate smooth gas replacement by slowing down the speed toward the end. Indeed, with a common molding method, the injection speed was set in 3 stages, with a gradual filling toward the end to prevent gas burning. On the other hand, when FFC was used to fill gently with the viscoelasticity of the resin, gas escape was facilitated. Moreover, by taking advantage of low-pressure filling, the mold clamping force could be reduced from 500 kilonewtons to 370 kilonewtons, and the material burning was improved by further enhancing the effect of gas escape. Also, in terms of simplifying conditions, the common molding machine controls the speed in 3 steps to fill gradually. In other words, it is necessary to find 3 positions to switch the velocity, but when using FFC, it is possible to mold with a single stage velocity and pressure, which means that only one point to switch the VP needs to be found. In addition, since only one velocity and one pressure are used, the molding conditions are simple and easy to set, which leads to ideal molding without defects. As we have explained, the FFC function is a single application, yet it can be expected to be effective against many molding defects. And the fact that it can be easily set up at the touch of a button will be a major attraction. In addition, zero molding has another function called MCM that enables molding with low mold clamping force. By combining with low-pressure filling with FFC, further effects can be expected, so please make use of it.